Problem number 2, draw the shear and moment diagram of the wave shown. So the first thing that we are going to do here is to compute for the reactions and the support. Here at point B, we have two reactions here. So we have the By and the Bx. But the horizontal reaction is equal to 0. So let us just denote this as reaction B. And at point D, we have one reaction at the roller. So we have here the reaction at point D. So in order for us to compute for the reaction at point D, what we are going to do is to summate moment at point B. So we have the summation of moment at point B is equal to 0, taking the clockwise direction as positive. This 30 kN here will create a counterclockwise rotation, so we have here negative 30 multiplied with the moment arm, which is equal to 1 meter. This 50 kN will create a clockwise rotation, so we have here plus 50 multiplied by the distance of 3 meters. And this RD here will create a counterclockwise rotation, so we have negative RD multiplied by the distance of 5 from point B. This is equal to 0. So computing for the value of RD, then we have negative 30 plus 50 times 3 minus 5x. This is equal to 0. Shift solve equals, and we have here 24 kilonewton. So we have 24 kilonewton. Since it is positive, so tama yung assumption natin that RD is directed upward. In order for us to compute for the value of RD, we have to summate forces vertical is equal to 0, taking the upward direction as positive. So we have here 30, which is directed downward, so that's negative. The RB is assumed upward, so that's positive. We have here 50 directed downward, so that's negative. And this RD here, which is equal to 24 kilonewton, is directed upward. So we have here positive 24 kilonewton, and this is equal to 0. So computing for the value of RB, then we have negative 30 plus RB, so that's x minus 50 plus 24. This is equal to 0. Shift solve equals, and we have here 56 kilonewton. So this is 56 kilonewton, and since positive yung lumabas na sagot, meaning tama yung assumption natin that it is directed upward. So first thing that we are going to do is to cut this member AB here. Then we would have for segment AB. So for segment AB, we have the limit from 0 to 1. And we have here 30 kilonewton downward. And if we cut in this section, then this distance here is distance x. Of course, in here we exposed the shear and the moment. Okay, so in order for us to determine the equation for the shear, so what we are going to do here is to summate forces vertical. So the shear is equal to negative 30, since yung nakikita lang natin na vertical force dito is 30 kilonewton, and meaning that is constant, negative 30 from 0 to 1. So at x is equal to 0, the shear at 0 is negative 30 kilonewton, and at x is equal to 1, the shear at 1 is equal to negative 30 kilonewton, that is constant. And if we are going to determine the equation of the moment here, so we have to summate moment at the section, and we have here moment is equal to this 30 kilonewton here will create a counterclockwise rotation with respect to this point, and that's negative 30 multiplied with the moment arm, which is x. Now what we do here is to substitute the value of x is equal to 0 and x is equal to 1 as our lower and the upper limit. So we have here at x is equal to 0, the moment at 0 is equal to 0, and at x is equal to 1, the moment at 1 is equal to negative 30 kilonewton meter. So we will be doing the drawing of the shear and moment diagrams simultaneously with our computation. So out of these answers ay mas sketch na natin yung shear and moment diagram for the segment AB only. So at x is equal to 0, the shear is negative 30. So we have here negative 30, and at x is equal to 1, that's still negative 30 since it is just constant. And this is a horizontal line. And this is our shear diagram for the segment AB. And for the moment diagram for the segment AB, we have here at x is equal to 0, the moment is 0. So we have 0 here. And at x is equal to 1, that is negative 30. So in here, we have negative 30. Since this is equation of a line, so we're just going to connect the 0 here and the 30 by a straight line. And this is our moment diagram. So this equation here is valid only for the segment AB. Okay, so let's continue with the segment BC. For the segment BC, what we're going to do is to cut anywhere between the segment B and C. So we have here. So for the segment BC, we have the limit from point B, that is 1 less than or equal to x, up to this point, which is 4 meters from the left portion of the beam, and that is 4. So this equation of this figure will represent the limit from 1 to 4. Okay, so at point A, we have here 30 kilonewton load, and at point B, we have the reaction RB, which is so this RB here is equal to 56 kilonewton, and this RD is equal to 24 kilonewton. The RB, this is 56 kilonewton based on the previous computation that we have. And this is our section here. So for the distance, this distance here is distance x. And since this is 1 meter here, this distance is x minus 1. So here at the section, we have here the shear and we have the moment. Now for the equation of the shear, so we have here V is equal to 30, that's downward, so it's negative. 56 here is upward, so that's positive. And V is equal to 26 kilonewton. So this equation here is the equation for our shear. So for the limit at x is equal to 1, of course the shear at 1 is equal to 26 kilonewton, and at x is equal to 4, we have here the constant value of shear, which is equal to 26 kilonewton. So the shear at 4 is equal to 26 kilonewton. So for the moment, we have here moment is equal to this 30 here will create the counterclockwise rotation, so that's negative 30 multiplied by the distance x. And this 56 here will create a clockwise rotation, so we have here plus 56 multiplied by the moment arm, that is x minus 1. So simplifying this, we have negative 30x plus 56x minus 56. So we have here the moment is equal to negative 30 plus 56 is 26x minus 56. So, and this is the equation for the moment of the segment BC. Now, in order for us to check whether we got the correct moment equation, what we are going to do is to take the derivative of the moment. So taking the derivative of this, we have the shear is equal to 26, and that is correct. Okay, so at x is equal to 1 and at x is equal to 4, so we will determine here the moment at 1 and 4. So what we are going to do is to type the equation, so that's 26x minus 56. At x is equal to 1, so calc 1, and we have here negative 30. So the moment at 1 is equal to negative 30 kilonewton meter. To check, so yung previous na sagot natin, that's negative 30, and it is correct. And the moment at 4, so what we do here is to calc 4, and we have 48 kilonewton. So the moment at 2 is equal to 48 kilonewton meter. Now, so what we are going to do is to sketch the shear and moment diagram for the segment BC. Okay, so we have here for the shear diagram, that's 26 kilonewton for x is equal to 1. So we have here 26 kilonewton. So bakit siya naging 26? Ito yung reason. Inakyat kasi siya ni 56 from negative 30 plus 56, that's 26. And we have here the shear at 4 is also equal to 26, since our equation dictates that we just have a constant 26 between B and C. So this is our shear diagram for the segment BC. Okay, so for the moment naman, we have negative 30 at x is equal to 1, so ito yon, and at x is, I'm sorry, this is 4, and x is equal to 4, that's 48. So 48 is positive, and I have 48 here. So if we are going to connect this to this point, titingnan natin yung equation natin. Our equation here is linear, therefore we will just going to connect this by a line. So this is our moment diagram for the segment BC. Now let's proceed with the segment CD. So for the segment CD, we have here the limit from the leftmost part of the beam. So this is 4, and the point D here is 6. So limit natin dito is from 4 to 6. So for the segment CD, we are going to cut over here any point between point C and point D. We have here 30 kilonewton, and at 1 meter here we have the reaction, which is equal to 56 kilonewton, and at 3 meters we have 50 kilonewton load. So if this distance here is x, therefore this distance from the point B up to our section is x minus 1. And if the distance here is 3 plus 1, so that's 4. So this distance here is x minus 4. Okay, so for the shear equation, so we have the shear is equal to all of our vertical forces, so that's negative 30 plus 56, that's upward, minus 50 because it's downward. So we have here the shear is equal to negative 30 plus 56 minus 50, and this is equal to negative 24 kilonewton. So we have here negative 24 kilonewton, and this equation here is the equation of our shear for the segment CD. Now we have the limit from 4 to 6, so at x is equal to 4, our shear at 4 is equal to negative 24 kilonewton, and at x is equal to 6, our shear at 6 is equal to negative 24 kilonewton, since this is constant from 4 to 6. And for the moment equation, we have here moment is equal to 30 times x. So in here we expose the shear and the moment. So we have negative 30 times x, because this will create a counterclockwise rotation, and we have this 56 that will rotate clockwise, so it's positive, multiplied by the moment arm, which is x minus 1. And this 50 here will rotate counterclockwise, so we have negative 50, and the distance is x minus 4. And simplifying this, we have the moment is equal to this negative 30x plus 56 multiplied by the quantity x minus 1 is just the same with the equation here in our segment BC. And if we are going to simplify this, we will have 26x minus 56. So gagawin natin, we will just copy this, 26x minus 56. So we have here 26x minus 56. Then we have 50. So this is negative 50x plus, that's 50 times 4, so it's 200. So simplifying our equation here, we have the moment is equal to negative 50 plus 26 is equal to negative 24. So we have here negative 24x, and we have 200 minus 56, that is equal to 144, so plus 144. And this equation here is the equation of the moment for the segment CD. Now, in order for us to check whether we got the correct moment equation, we take the derivative of this moment here. So by taking the derivative of the moment, so that will give us the shear, and that is negative 24. Now, since the derivative of the constant here is equal to 0, so meaning we got the correct moment equation. And if we are going to compute for the moment at x is equal to 4 and at x is equal to 6, so what we are going to do is to substitute the value of 4 and 6 to our moment equation, and we have here negative 24x plus 144. So let's substitute 4, and we got 48 kilonewton. So we have the moment at 4 is equal to 48 kilonewton meter. To check, so we have 48 kilonewton meter here, and yun yung pang check natin. So dapat nagmamatch siya dun sa sagot natin sa sinundang segment. And we have here the moment at 6, so calc 6, and we got 0. So we have here 0. So at x is equal to 6, we got 0 moment. And for the shear diagram, we have here negative 24 at x is equal to 4. So this is negative 24. And at x is equal to 6, we get also negative 24, and that is constant. So from the point C to point D, we have the constant negative 24. And this is our shear diagram. So this 24 here will be, and this shear diagram here will be closed by the reaction at D, which is 24 kilonewton upward. So from here ay isasara niya na yung ating shear diagram, and that would be equal to 0. So kapag hindi nagsara yung shear diagram mo, magtaka ka na kasi ibig sabihin meron siyang mali. Okay, so for the moment equation, we have here the equation of the line. So kukonek lang natin itong 48 to 0 by a straight line, and this is our moment diagram. Ayan. So the possible questions na itatanong sa atin ay ito. What is the value of the maximum positive shear? So the answer is 26. What is the value of the maximum negative shear? So the answer is negative 30. And of course, that's kilonewton. And what is the value of the maximum negative moment? And that's negative 30. So that is located at the 0 shear. And what is the value of the maximum positive moment? That is 48 kilonewton meter, which can be found at the location of the 0 shear. Now, another question here is, what is the value of, or the location of the point of inflection, this distance x here from the point A? So, hindi natin pwedeng gamitin itong equation na to ng moment sa CD kasi yung point of inflection natin ay nasa BC. So, therefore, yung gagamitin natin ay yung equation sa BC. So, we have here the equation for the moment at BC. So, we let this moment is equal to 0, and that is 26x minus 56. So, solving for the value of x, then we have here 56 divided 26. And we have 2.154. So, we have here 2.154 meters. So, meaning this x here is equal to 2.154 meters from point A. So another option in order for us to compute for the location of the point of inflection is to make use of the ratio and proportion. So gagamitin ko na lang siya sa next video natin. Iso-solve natin to ulit using the area method.